And so here we are for part 2 of our example. Let's just jump right in and get this finished. So we have our standard deviations from our two pools. So now we have to calculate out our pooled standard deviation. And so let's get started with it. So we're going to equal, it is the square root. And we're going to take the, let's see, sample size 1 minus 1. And then we're going to take this and actually let's preload our, I think we're going to need 3 parentheses in here. So let's just get them going. So I've got my sample size from 1 minus 1. And then I'm going to take that whole thing and I'm going to multiply it by our standard deviation from sample size 1, and then squared. And I will add to that my sample size of 2, sample size 2 minus 1. And actually we want that to be in parentheses, make it nice and clean, and then we're going to multiply that by our standard deviation at 2, and that we're going to square that. Okay, and so that is our numerator. Now we're going to go from our denominator, and our denominator is going to be our degrees of freedom. So sample size 1 plus sample size 2 minus 2, because we have the 2 sets of independent data. And I believe that is everything. I think I might have 1 extra parentheses. We'll let that fix itself. And so pooled standard deviation is not looking right. 1 second, let me check this. Okay, I didn't want to make you sit through troubleshooting my equation, but it looks like that I have 1 too many parentheses in here. So we're going to have to remove 1. I think it's that one there. I think that screwed it up. And so there we go. So I had to parenthesis here and like here, so it was square rooting it before doing everything else. We wanted the square root at the end. And it's always important to take a look at your equations, especially when they get more complex. In fact, when you got an equation that's that complex, it's sometimes easier to break it up into smaller chunks. Okay, so there we go. And so now let's look at the standard error of the difference. And so that's just going to be our pooled standard deviation times the square root of our inverses of our sample size. So 1 over sample size 1 plus 1 over sample size 2. And I got sloppy with those, and so we put it in. So there's our standard error of the difference of our salaries. Now we have our degrees of freedom. So what do? It's our sample size minus 2, because we have the 2 sets of data. So our degrees of freedom are 379. So now the multiple, since this did come from the book, multiple, what they are talking about, this is we're going to run our t-test. We're going to run our two-tailed t-test, so t inverse, both tails. We're going to do our probability, so we're going to do our confidence level. Now we've done it a couple different ways. Let's just do 1 minus 95. That gives us our 5%, which is our alpha, which is what we're trying to calculate out. And we have a lot of degrees of freedom, and so our t-value is 1.97. And so the last thing that we have to do is to calculate our confidence interval. Now we're doing this based on our average between the two. Not our average, our standard deviation between the two. So we're going to start out here with the sample mean difference. And then we're going to subtract from that, because we're doing a plus or minus, our multiple. So that's our t-value times our standard error. Did I grab the right one there? No, I did not. I grabbed Oh, I grabbed the standard deviation. I want the standard error. Let's go back. Pooled standard error right there. And so we got negative 220,000. I'm going to drag that down. I'm just going to change this minus to a plus. Okay, and so as we look at it with a 95% confidence interval, our differences between the salaries runs from a negative 223 to 1.4 million. Based on this result, we have a zero. We cross a 0 point. Therefore, we cannot provide any statistical evidence that the population means differ, because that negative sign, that blows it. If the lower limit and the upper limit were both positive, then we would be able to say with a 95% confidence that the difference between those salaries would have ended up within that range. But once again, we went negative, therefore statistically we cannot say anything about the difference in the data. All right then, that finishes up this problem. If you have any questions, please let me know. Otherwise, I'll see you next time.